Today we are going to be looking at ordinary differential equations ODE. So by definition, it is an equation involving one dependent variable and a derivative with respect to one independent variable. So from the examples over here, we can see in example 4, dx over dy plus y is equals to 2x. So from this example, we can see that y is a dependent variable and the derivative of y and with an independent variable x. So from this example, y is the dependent variable, dx over dy is its derivative, and 2x is an independent variable. So this means that this is an example of an ordinary differential equation. So the same thing as the one in number 1, we have y prime prime plus 2y prime plus 2y is equals to sine x. So it has one dependent variable y. There's no other there's no other dependent variable like maybe any other letter like c or any other like z. It is only dependent y and independent x with the derivative of the dependent, that is y prime prime and 2y prime. So it can have more than one of the derivative of the dependent, but it will have only one dependent variable, that is y. So there's nothing like z or z or d. So we have the dependent and independent. So in the second example, y prime plus 2y prime plus 2y is equals to exponential x. So this is an ordinary differential equation. Also, this is an ordinary differential equation. So that is why in the definition, let me take it again. It is an equation involving one dependent variable and a derivative with respect to one independent variable. So with this definition, you can use it to identify if an equation is an ordinary differential equation. Okay, note y prime is also equal to the y over the x. This is the first differentiative or first derivative. Y prime prime is equal to the square y over the x square. This is the second derivative. Y prime 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 is equals to the cube y over the x cube. So and so on. So don't forget this, because in most of the examples or equations, they are interchanged. So let's move on. Order of an ODE. So ODE is the short form for ordinary differential equation. So order of an ODE, it is the order of the highest derivative in the equation. It is the order of the highest derivative in the equation. So over to our example above. So let me begin with example 4. So from what I said it is the order of the highest derivative. So in example 4, what is the highest derivative? Okay, that should be the x over the y. That is actually the only derivative. So, and the order of this derivative, this is the first derivative. So by so doing, the order of this example is going to be 1 since it's first derivative. The order is equals to 1 since it's the first derivative. So coming over to this example 3, to find the order of the ODE of the equation. So it's going to be the highest order, and that should be, we have the square y, this is the second derivative, the y over the x, first derivative, the cube y over the x cube, This is the third derivative. So I guess 3 is higher than 2 and 1. So the order of this equation, this ordinary differential equation, is 3. So we have order equals to 3. So then in the second example, the order is 1. Remember, I told you y prime is also the first derivative. And since it is the only derivative here, so it's going to be the order, that is 1. So in this one, we have y prime prime 2y prime. So automatically, from the definition, the order of this equation is the highest derivative, and that is y prime prime. This is the second derivative. So order is 2. So let's go over to the degree. Degree of an ODE, it is the power of the highest order derivative in the ODE. So after getting the order of an ODE, the next thing that follows is the degree. So from example 4, dx over dy, we can see here that this is actually raised to power 1. And anything raised to power 1 is that number. So there's an invisible one. If you can put it here, but it's of no use in mathematics, it's of no use because it's going to give you the same value. Anything raised to power 1 is that. You get that value back. So the degree of example 4, equation 4 is 1. So an easy shortcut of getting the degree is once you have gotten the order. So from this one, the order is 3, and that is from the third derivative. So from the definition, the degree is the power of the highest order. So what is the power of the highest order? Here is 2. So it means that our degree is 2. So in example 2, equation 2, we have y prime plus 2y is equal to exponential x. The order is 1. And this is actually raised to power 1. There's an invisible one in outside. So the order is 1. The degree is 1. So from this one also, the order is 2 and is also the degree, and also the degree is 1. So the main thing is just to understand the definition that the order of an ODE, it is the order of the highest derivative. So in any equation, you look for the highest derivative, then that value of the derivative is the order of the equation. Then the degree of an ODE, it is the power of that highest order of the equation in the ODE.